Okay, to continue on with our question. Okay, so our next question is, how many footballers, so hang on, I'm just going to get rid of some of this. So our next question is, how many footballers have a chest size between 103 centimetres and 111 centimetres? Now this is when it gets a little bit trickier, because this isn't just a standard they're both in the same standard deviation, one's below, one's above, bang, it's that number. But because we know all of this stuff and where these lie, we can work that out. So between 103, which is here, and 111, which is here, so 1 standard deviation above and 2 standard deviations above, what percentage lie within this part of the graph? So, how are we going to work this out? So we need to find the shaded part. So we know that between the mean and 2 standard deviations is 47.5%. So in between this part, so X bar to 2 standard deviations above equals 47%. And we know that from X bar to 1 standard deviation above equals 34%. So how much lies in here? I'm just going to bring the equation over here. We're going to go 47.5%, take away 34. Put that into your calculator and we get 13.5%. So 13.5% of footballers have a chest size between 103 centimetres and 111. Alright, now this, I could write all the formulas out for this, but there'd be pages, probably about 20 pages long, whereas this is when it comes to reasoning. So you girls know, this is when you have to use your brain, so it's not just looking at it and being like, oh, that. Alright, you know how much is in here, you know how much is in here, let's work out this. So this is a bit of problem solving using the rules you already know. Okay. So right now I'd ask any questions and you probably have a million, but I can't answer them because I can't hear you. Alright, so next question is, find the probability that a randomly selected footballer's chest measurement is between 87 and 111 centimetres. Alright, clear the board. Oh, it's getting messy. Love it. Alright. So notice for the whole question, our standard deviation doesn't change because this is our data and our raw data doesn't change. Okay, so find the probability that a randomly selected footballer's chest measurement is between 87 centimetres and 111 centimetres. Alright, now it's asking for probability. We're working in percentages. So let's keep working in percentages and then at the end we will convert to probability. So first of all, let's find the percentage that a randomly selected footballer's chest measurement is between 87 and 111 centimetres. So we need to find what percentage of footballers lie between these two numbers. So 87 is at 1 standard deviation below the mean and 111 is at 2 standard deviations above the mean. So with our X bar, we know that between 1 standard deviation below and the mean, there is 34%. And we know that between the mean and 2 standard deviations above, there is 47.5%. There is other ways to work this out. This is just the form. This is just the way I'm going. All right. So let's plus them together. 34 plus 47.5 equals 81.5. So 81.5% of footballers have their chest size between 87 centimetres and 111 centimetres. Now let's change this to probability. So to change this to probability, we need to divide by 100. So we end up with 0.815. So there is a 0.815 chance or probability that this randomly selected footballer's chest is between 87 and 111 centimetres. I could keep doing so many of these examples. It's probably best if you just keep going over and watching this one and try and do them yourselves, because otherwise I'll be here more than all day. Okay, so next question is, find the value of K such that 16% of chest measurements are below K centimetres. Well, what the hell is K? I don't care what K is or who K is or what the K is going on, but let's find out anyway. So K, let's do this. Okay, so it's asking us find the value of K such that 16% of chest measurements are below K centimetres. So it's saying if we want 16% below a certain number. I'll say that again. 16% below a certain number. And that certain number we are using as, at the moment, as K. What does K equal? So, look back through your notes. 16% below. Now, which rule does that relate to? Oh, I think I heard you. Oh, well done. All right, so it relates to the 68% rule, which is with the 1 standard deviation. So we know that 16% of our data lies within here. So you just need to know your rules. All right, so 16% of our data is in here. And what number is that at? That's at 87. So K equals 87. Now, sometimes it might not be that straightforward. Sometimes it might ask you for a number, and it might be talking about how much of the players are below, or we want this many percent, and that percent might correlate to 2 standard deviations above the mean, but it wants to know what percentage are below that. So you would need to work out this much, which would be 50. Then you need to work out how much is in here, which would be 47.5. You add them together, and that's how many is below that. Right, so sometimes it won't be that straightforward. Sometimes you will need to think a few steps beyond. All right, but you've got those starting blocks there. Okay, so back up. Oh shit, did I just do that without that? Oh no. Oh, I'm a doofus. So we had our 16% there. I am so sorry. Comment in this if it doesn't make sense, and I'll redo this section again. All right, I'm going to stop there before we move on to our... Oh, hang on, how much is left? Yeah, actually, no, I'll keep going. This is just a bit of notation. All right, I've got 1 minute before I run out of time. So, our next bit we're looking at is some notation. Now, this is to do with this is a completely different question than we've looked at, but let's have a go at it anyway. So it's got nothing to do with the footballers, nothing to do with that mean or that standard deviation. This is completely different. So this is our notation. So given that x squiggly line n3, 0.1 squared. What the? All right. Now, what this means is this one here is our x bar. This one here is our standard deviation, except we're not going to square it. So forget that square, pretend it's not there, because it's actually talking about the variance. Don't worry about the variance at the moment, but you just need to know when you're dealing with this, don't square it. Alright? So, I've run out of time.